Waiting for the recording to start. Okay. All right. Good morning, everyone. Welcome back. And so what we're going to do today is, so yesterday we finished off the initial discussion on normalization that got us to the third normal form, right? So hopefully you remember from yesterday, or if you've watched the video since then, if you didn't attend live, hopefully then you have a good understanding of how we get from an unnormalized database, a single table-like structure. It doesn't even have to be a real table. It just has to be a table type structure, and you'll see an example in just a moment. And hopefully you have a good understanding, at least kind of the idea of how to get to the third normal form. What we're going to do today is I'm going to use an example set of data with columns and data items and stuff. And what we're going to do is we're going to process it from the unnormalized set that it starts with, and it's going to get all the way into a set of database tables that are in what we call the third normal form. Okay, I'll show you kind of how to write queries to make that happen, and then basically what this is let me take a look here. I want to make sure I get the right line item. I got to pull up the PDF for this for the group assignment. So this would be the item number 3 on the deliverables. So let me just go ahead and I'll share my screen for this and just show you what I'm talking about. Come on. All right, there we go. All right, so what we're going to do today is I'm going to show you an example, so how you can get this thing done, okay, and how you can you know what, and also while I'm at it, I'm going to go ahead and show you this one if we have time as well. Okay, so I'll show you 2 different ways for doing this, for doing the number 3. Yeah, really, I mean, we're basically going to do an example project here today. It's kind of basically what this is. So, okay, so let's go ahead and get right to it. All right, so here's an example. I called it the App Store example. It's got here, what, 10 columns. So clearly not nearly the size of what I'm expecting for your group project. Okay, not even close. All right, you need, I think, 30. Is that right? What did I say, 30? I believe. Yeah, 30 data items. And when I say data items, this is not a data item. Okay, like this is not 4 data items. All right, this is a data item. So what we're talking about is a category, is a column. Okay, so you need, so here we have 10. Here I have 10 columns, right? You need 30, right? And I would say also you need a good set of data. So here I have about 14 individual rows. If we were to make this into a first normal form table, we would end up with 14 rows. This is probably not a good, for a project of the size that you guys are doing, this is probably not a good amount of data. All right, this is just an example. It's a very small example. All right, so let's get into this. All right, so basically what we have here is we have, these are our column names, right? So let me do this. Let me, where's my, there's data, create a filter. Can't filter across vertical mergers. Dang. See, even sheets can't do this. All right, so we'll do this. We'll do it like that. So these are our column names, right? And so what I can do is I can automatically say, okay, this is probably what my table will look like. And I could go ahead and create here a table with those 10 columns. Okay. But the problem is that this isn't really one row, right? This is really kind of 3 rows, right? You guys see that? Because really what this represents is that this user has downloaded this game. And this user has downloaded this game. And this user has downloaded this game. Right? So one way, there's 2 solutions that I will talk about here. One way is going to be to unmerge all of these. All right, if I can get that, unmerge. Okay, and then copy this there. Okay, and if I do that for all of these, right, what am I going to end up with? I'm going to end up with 14 unique rows. Right. Which, by the way, if we look over here at this table, we'll see if it will come up. It's being slow today. All right, you see that's what I've done here. And actually, I think one of them I added Turkish into this Amazon shopping, which I don't think I oh, and Amazon Prime Video. Actually, I added French into here. Actually, is what I did. Anyway, so I changed it from here. So actually, let me go ahead and change it back so that it's not English to Turkish. I want to change it back so it's not the same. All right. So here now I have a table with all my data items, right? An actual database table. But here's the problem. Here's a problem. Is I don't have a primary key to find, right? I don't have a primary key to find. All right. So now what I could do is, and this was where one of you, I think it may have been Murat, I'm not sure, yesterday suggested, you said, well, hey, can we just create a new column? We could just create a new column with a unique identifier, but the problem with doing that for this table is that what we'll see is that this table will actually end up representing something, because right now, what does this table represent? This table represents every time a user downloaded a game, right? So it's the crossing of if a user downloaded a game, we want to see that. And the really important thing here, the really important part of this is that we want to know, we want to still be able to have a quick reference for that user downloaded that game. And that's the important information, is the user, or not game, app, sorry, there's a bunch of different types of apps. The user and the app, right? And we can see in this table some of those update anomalies we talked about yesterday and last week. Is what would happen if I were to change something like Netflix, change it from entertainment to game, but accidentally only changed this row, right? Or what would happen if the user email got changed, but only for this one here, right? Then there would be a problem, because there would be inconsistent data, right? There would be data anomalies there. All right. So what we first need to do, so now we have what I've called UNF, unnormalized form database, and we need to add a primary key to this table. Okay, so we need to get it to the first normal form. So what do you guys think? Well, let's first talk through functional dependencies. What are some of the functional dependencies that exist here? Okay, and you can either look here or here, either way. And what I'll do is I'll go back. Make it all merged again and change this back to. So either one. I don't know how to show both of them at the same time, so that's unfortunately not going to be an option. So, all right, just throw out a few functional dependencies. Actually, what I'll do is I'll leave it here, and you guys can use the A, B, C, D, E, F, G, H, I, J. So you could say, if you think that A is dependent on C, then you could say C determines A, like that. Okay, that is not one. I hope you guys know that that's not one, but you could write it that way. They need to have like a no emoji, like they have a thumbs up, but they need to have like a no, that's not right. Okay, let's see. Murat says A determines B. Yeah, right. The app name determines the type. Yeah. Amazon shopping is a shopping type. Yeah, that's good. And A determines D. Yeah. A determines E. Yeah, sure. A determines F. Uh-huh. A determines H. Yeah. Totally. Seems like A determines a lot of stuff, doesn't it? Oh, and by the way, you can write that like this, Murat. I'll agree with all of yours. What you could write it as is like this. A determine what you've done. You could write D, E, F, and H. So you could write it like that as well. Maybe I should have put an app that costs something so that we could also see that one. Because we might be tempted to think that for this relation, for this table, that A is a primary key. But that would not work. And the reason why is because A does not determine either of these, because among us, right? I've never played this, but I've seen a lot of people have, apparently. I'm assuming it's a fun game based on the fact that so many people I know are playing it, right? But among us does not determine username, does it? Because lots of usernames have downloaded it. Same thing with Netflix. Netflix does not determine username. So A cannot be our primary key. All right. But A does determine a lot of stuff, doesn't it? It determines what type, determines the age, language, size, developer name. Yeah, I'd agree with that, Murat. I would say A and I are the primary key together for this data set because what this represents is a user downloaded a game. And so the user or downloaded an app. I keep saying game. The user downloaded an app. Oh, by the way, before I forget, because I used this App Store example because no group has taken this on as a project topic. So therefore, that project topic is no longer available since I'm walking through it with you, because I think that would be unfair to the other groups for you to have an example solely dedicated to your group. So because no one's taken this project, no one can take it now. Okay. All right, so A and I are the primary key. So we'll say because of that, AI determines, we'll just say all others. So we would write those out. We would say B, C, D, E, F, G, H, I, J, or A, J. All right. Okay. So we have this AI. So let me show you kind of how we can even show that that works in our example data. Is if I were to say I want to make app name primary key. This is going to say, oh, hey, no, you can't do that. There's a duplicate entry. If I were to say, okay, I want to make the username the primary key. Oh, no, there's a duplicate for that. If I said I want to make the app name and let's go with developer ID primary key, it's going to tell me, oh, there's a duplicate there too. But if I say I want to make the app name, the username, the primary key, successful. What I'm trying to show you here in this example is if you select a set of columns and say, I want that to be my primary key, and you get an error, if you get a, hey, there's a duplicate entry, you know that you've selected a bad option for a primary key. Okay, so by the fact that we were able to successfully do this, it means that at least for this example data, this makes a good primary key. Okay. So now that we have a primary key defined, we have a first normal form database. Yay! Like, I want to do, is there like a celebrate emoji or something? I want to do, is there like an applause? Okay, this is the closest one I can find here. There we go. All right, so yay, we have a first normal form database. Great job, guys. All right. Now, where do we go from here? How do we get from first normal form to second normal form? Do you remember? You guys remember how to get from first to second? Let's see. Let's see. Let's pull it up. And what I'm going to do here is I'm going to unshare for a second, and I'm going to, instead of sharing just the window, I'm going to share the whole screen, number 2 here. Okay. All right. Let's see. So how do we get from first to second? Let's see. Okay, so first, all right, so we have a relation in the intersection of each row and column contains one and only value. We did that. We got an attribute or group of attributes to act as the key. Good, we got there. Identify the repeating groups. We did that. So each cell has only one value. We're good there. There's none of, so in other words, what that is we don't have this going on anymore. Okay, we don't have this. All right, we have everything, you know, yeah, there's some duplicated kind of information here, but that's okay because this is first normal form. Because we haven't gotten to anything higher, this is okay for now. All right, let's see what else. So we did that. I'll show you a second way to do this in just a moment. All right, so how do we get from, so second normal form? we want to get rid of all partial dependencies. Do you remember what a partial dependency is? You guys remember what a partial dependency was? What's a partial dependency? It's a tough one, isn't it? Is it tough to remember this? Let's see. Let's go back over here. Partial dependency. Let's see. Let's go back to. I think it's back above this there. Not transitive. Full functional dependency. Okay, so a partial dependency is any time that we have a functional dependency where it's not dependent on both of these together, it's dependent on one of them. Okay, where the extra attribute doesn't really help any. Like we don't need that. All right. So if like you had staff number, staff name determines branch number, well, yeah, but staff number alone determined branch number. So we didn't really need the staff name included as part of this dependency. It's just extra, it's redundant, right? So if we look at this example here, okay, remember the combination of A and I, but by the way, let me do this. Let me unmerge all this because I want to show you. Oh, that's not, ooh, no. Ah. Oh, I didn't want to merge. I'm going to unmerge. Okay. So I'm gonna kind of make my spreadsheet look like my table, and there's a reason for that. Okay. Because what I want to do is here, this we're going to call this first normal form. Okay. And what we're going to do is we're going to highlight this and this, whatever color you want to use, and that indicates that this is our primary key. Okay. All right. So, are there any partial dependencies that exist? Is there any column B, C, D, E, F, G, H, or J that is dependent on the primary key, but really it's just dependent on either A or I alone? Like we don't really need both. What do you think? Yeah, I determines J. Our user email is dependent on the username, isn't it? Right? We do have a partial dependency. Right. Yes, again, I would say that all of these columns are determined by A alone. We don't need I to determine who developed the game, do we? Okay, so these are partial dependencies. So the way that we handle partial dependencies is we create a new table. Okay, let me create a table based on our username, user email, for example. Okay. So we're going to create table, and we'll call it the user table. user. Let's see. And we'll give it the same column as username, bar, char 15, I believe. And here's the thing. Is that the left-hand side of that functional dependency, the I determines J, right? That's going to be, the I is going to be the primary key of the new table we're creating. Okay. And then user email, var, char. I did it as a 30. Let's make it not null too. And primary key constraint on what did I do wrong? Oh, I think user is a reserved word. It's called user info. What did I do wrong? Let's try that. Oh, let's try that. What did I do wrong? I think it's been a while since I've written a create table from scratch. Let's see. I'm doing something not quite right over here. Let's see. That should be it. Oh, you may be right. Good call. All right. Thank you, sir. There we go. All right. So now we have a user info table that has no data in it and has username, user, email. So we need to put that in there, right? So we need to put our information in there, right? And the way we can do that is we can do an insert statement, right? Insert into user info. We know what columns we want, right? We want the username and email from the other table, right? We want to select username, user email from our UNF table. We don't need a where clause, do we? I'm going to copy this because we're going to do something with it in just a second. Okay, so we can go. Wait a second. Duplicate entry. What did I do wrong? What do you think I did wrong? Well, but why not? What could be the primary key? But remember, this is just the user information table, right? Sometimes if you get something that you're not expecting, because remember, what's going to happen is we're going to get rid of this column from this table, right? We're going to keep only this column, and this will become the foreign key to our other table. So what we would like to end up with, if I can show you this, let's see. We would like to get rid of all duplicates. No, not delete rows, delete cells. All right, so this is a duplicate, that's a duplicate, that's a duplicate. So we want to get rid of that. Okay, that's duplicate, the duplicate, that duplicate. Right. Right. So this is what we would like to get, right? We would like to get rid of this column. This is what we would like to end up with, is where this points to this, right? And this points to this, and this points to this, and this points to this, right? And this points to this. Right? So we'd like to end up in this situation. That's what we should be inserting into. So, sometimes if I go to run something and I get an error or I get something I'm not expecting, what I can do is I can take out the insert. I can just run just the select statement and see what happens. Now, does this look like this? No. That's way too many rows, right? So what can I do to make this work? No, that's not what I meant to do. We could, but there's even a more simple way. I think that would work. Let me see. Select. Let's see if that would work. I don't know what that would do. It did. Yeah. There's also another option. So that's one we could insert into using this. That's what I was thinking, Suleiman. So either one should work. So if we did same thing, right? So now we can see this is what we want our user info table to look like, right? Into user info now. Go. We inserted those 5 rows. If we go and look at the user info table, there we go. If we go look at our UNF table, we can get rid of this column now. Okay. And how do we do that? Which column are we dropping? Which column are we getting rid of? Right, user email, because it's not the. Do you really want to do this? Nervous. I'm nervous. All right. I shouldn't be nervous. I should not be nervous. Why? Because that data's gone from here, but it's not gone completely. I can still get John Doe's email address by looking in the user info table. All right. Did we get rid of all the partial dependencies? So we're moving this into second normal form. Did we get rid of all partial dependencies? Is there anything else that's partially dependent on the primary key? I think one of you set it up above, actually. Yeah, Murat, you said it. That A determines all of this, right? A determines all these other things, right? So what do we need to do? We need to do the same thing. We need to create a table. Okay, and this time, instead of writing that create table script, I'm just going to create it using this fun little user interface. Let's see. Actually, I need to create a table with how many columns? One. Remember, we got to include the primary key. So 1, 2, 3, 4, 5, 6, 7, 8 columns. Oh, app info. Let's see. App name, and it was a varchar 30. I think I said it as. What was the next one? It wasn't app. It was type, right? Type. It was a varchar. I think it was 15. Oh, I didn't do. Oh. I need to drop the table. Man. I need to drop my table. Can't believe I did that. All right, let's try again. 8. App info. Let's hope it doesn't not like this. Sometimes it doesn't like it. Okay. App name. Let's go back. Varchar 30. Type. Varchar 15. What was next? Cost, age, language. Cost was a double. Age was an int. Language was a varchar. I think I did 255 on this one because I wanted to be able to list a bunch of languages. What's next? Size, developer ID, and developer name. Size was a double. Developer ID was an integer, and developer name was a varchar 30. Okay. And let's make app name not null. And we won't be able to put a primary key on here just yet. Oh, actually, there's primary. So we're making app name primary key. Okay. Does that work? Yes. Okay. Boy. What don't you like here? I don't know what you don't like. Okay. All right, so now we have our table, right? And the same way that we did before, the same thing we did before, where we wrote a query, an insert query, into our app info. Insert into app info. And we want to do the same thing. We want to do all these columns. App name, type, cost, age, language, size, developer ID, developer name. right? From UNF. Right. Oh, just like we did before, we need to make sure we remember our distinct. Always retain the query just in case there's a problem. Well, they liked it, right? So let's see what's in our app info. Hey, that's nice, right? That looks nice. And then we want to go back to our UNF and we want to get rid of all of the things that are not the primary key of the new table. So we need to get rid of type, cost, age, language, size, developer. Why? Because all of that data, type, cost, age, language, size, all of that is in our new table that we just created. So we can say alter table UNF drop column, and then just drop all of the ones that are not app name. Right? Type, cost, age, size, but not username. Right? We want to keep username because that's the primary key to the other thing, right? Let me drop columns. What do you do? What do you not like? Why don't you like my commas? Okay, I guess no commas here. Do you really want to drop these columns? Make sure type, cost, age, language, size, developer ID. Okay. I guess I got to do them one at a time, huh? Yeah. Actually, you know what? I can do them like this. You think you're going to trick me? I got you. Okay. And the reason we can drop all these again is that all this data is now contained in the app info table. Oh, I need to drop each one. Oh, okay. Drop type, drop. Oh, okay, that makes sense. All right. So now the only columns that exist in our original table are these two. Right. So we've gotten rid of these. In fact, what I'll do is I'll do like this, and then we'll take a break after I finish doing this. Okay. We can move this over here. We can delete these columns, and then we can delete all of our duplicate information. All right. So now what do we have? We have an app info table. We have a user info table, and we have this table that represents a user that has downloaded an app. And notice here, there's no columns in here that's dependent on the primary key, but also dependent on a subset. So there are no partial dependencies in our table here. There can't be any partial dependencies in this table because the primary key consists of only one column. And the same thing is true here. There cannot be any partial dependencies here because the primary key consists of only one column. So here we have an example that is in second normal form. We are good to go. All right, so here let's before we take a break, let's make Dancing Man come out again one more time because we got second normal form, guys. All right. After the break, we'll move this into third, and then I'll talk about through an example of how to do it a slightly different way. Okay. All right. See you guys in about 10 minutes.